For the last few years, the standard approach to AI has been conversational. You type a prompt, wait for an answer, and execute the work yourself. Now, the industry is transitioning to autonomous delegation. The difference lies in continuous execution. Instead of querying a chatbot for immediate one-off information, users are deploying local agents. An agent is a program that runs directly on your machine, continuously executing bounded tasks in the background, without needing a manual prompt for every single step. Mastering this shift from asking for answers to assigning workflows dictates how quickly small businesses can scale their operational bandwidth this year. Among small teams, the most practical deployments of AI are currently focused entirely on high-friction administrative work, rather than open-ended creative generation. Small business owners are feeding raw bank statements into AI tools to automatically structure profit and loss reports. Development teams are reading business proposals to build software MVPs. An MVP, or minimum viable product, is an early, stripped-down version of a product with just enough features to be usable. They are doing this while establishing strict security guardrails from the start. Educators are utilizing these tools to automatically generate daily course syllabi, saving dozens of structural planning hours before a semester even begins. The immediate return on investment for AI comes from automating mundane, repetitive data administration. Running a local autonomous agent, like Claude Cowork, requires treating the software like a newly hired employee. It demands a strict structural onboarding phase before it can do anything useful. This diagram illustrates the specific local folder architecture required to bound the agent. You must build dedicated folders for project files, output containment, and strict style guides.
This includes an anti-AI document that bans specific phrases and enforces exactly how the output should sound. In a recent test case, an agent was pointed at a messy desktop and told to organize it. It successfully audited, categorized, and sorted 54 scattered screenshots into the correct folders, and even isolated 22 of them into a separate deletion bin for final review. Deploying an agent successfully means abandoning the open-ended search bar mentality. You have to establish strict environmental rules and distinct project boundaries. These new workflows are currently quite fragile. When instructed to process a larger batch of those desktop images, the system hit a 2,000 pixel dimension limit. The agent completely crashed and failed to finish the task. This gauge represents computational resource cost. Autonomous processing consumes tokens, which are the basic units of data, like word fragments or image pixels, that an AI uses to process information. A single day of testing these local agents completely drained a monthly premium token allotment, dropping to 0 in a matter of hours. Granting an autonomous agent direct credentials to navigate web browsers or organize local hard drives introduces severe security vulnerabilities. If the agent misinterprets an instruction, it has the access required to delete essential files or expose private data. We are currently in the babysitting phase of AI agents. Workflows must be strictly batched, heavily monitored, and scaled with extreme caution. Users are weighing these high-control, high-friction local agents against integrated walled garden ecosystems like Google Workspace, which offer seamless convenience but require trading away layers of data privacy. Assess your own repetitive tasks to determine your exact risk profile. Next week, we will explore unified multi-LLM workspaces. An LLM, or large language model, is the underlying AI engine that powers these systems. By bringing multiple models into a single secure chat, we can mitigate workflow limitations without surrendering local control.